In this video, we'll discuss strong acids and bases. Strong acids completely dissociate in solution, where weak acids partially dissociate. Notice that we have only ions as a product, but over here we have ions and the original substance. So that means that you only had partial dissociation because this didn't dissociate completely. It's important to memorize your strong acids. All of these are the strong acids. Any other acid is considered a weak acid. Notice that they all begin with H. Those are indicators that it's an acid. Now, strong bases are similar to strong acids because you have complete dissociation in solution. Metal hydroxide is a base, complete dissociation. The fact that you have OH hydroxide in that solution, that's an indicator that this is a base. Complete dissociation means that it's a strong base. Your weak bases, you only get partial dissociation. Notice that you had NH3. It generates ions. One of those ions is hydroxide, an indicator that it's a base, but this NH3 did not dissociate completely. That makes it a weak base. Now, NH3 is the weak base that we will see the most, but there are other weak bases. Now, the common bases, the strong bases, you need to memorize these. There's only 4 of them, so it shouldn't be that difficult. So we'll get these examples like this where you see a compound. So what you're doing is you're going to determine if it's ionic, molecular, strong acid, strong base, weak acid, weak base. And we look at our indicators. So indicator number 1, we see hydroxide. That's an indicator that it's a base. Is it strong or weak? Well, let's see, did we get complete dissociation? No, we still have some of our original compound. So that's going to be a weak base. And then this compound, is it an ionic compound or is it molecular? Well, I don't see a metal, so it's a molecular compound and it's a weak base. Next, we see hydronium as one of the major species in water. But we see that some of that HF didn't dissociate. So we have an acid because of the hydronium, but we only have a weak acid. Now remember, all acids are molecular. And if you don't have complete dissociation, it's a weak acid. NaCl, I see no hydronium, I see no hydroxide. Metal, nonmetal, it's ionic, but it's not an acid, it's not a base. KOH, I see hydroxide, base. I see complete dissociation. I see a metal and I see a hydroxide. So metal hydroxide, that's an ionic compound. Complete dissociation, strong base. Now, if you want to go the other way, if you know the formula and we know that the acid or base is weak or strong, then we can predict the most prevalent species in that water, in that solution. So HClO2 is a weak acid. We know it's an acid because it starts with H. That's an indicator that it's an acid. So we'll get hydronium, or in this case, it'll be H plus ions. We lose the hydrogen, so you have ClO2 negative, but it's weak, so we still have some of the HClO2 that didn't dissociate. HF, weak acid. We have hydrogen ions, we have fluoride ions, but since it's weak, we only got partial dissociation. HI, strong. So we got total dissociation between hydrogen and iodide. And then weak, we will get some dissociation, but not complete dissociation. We still have some of that H2CO3 in solution. But notice that we lost one hydrogen, right? It's still, your anion is HCO3 negative. We only lost one hydrogen, so keep that in mind.